In this lesson, we are going to be solving systems of equations using the elimination method. Here are some steps to follow as we are working through this method. So our first step is very specific, and it states that each equation in the system is in standard form. And so if you can recall that is the form ax plus by equals c. The second step is to choose a column of opposites. And hopefully that will make a little bit more sense as we get through some of these examples. Step 3 is then to combine the two equations. And then after we have eliminated that variable, then there will just be the one variable to solve for, which is step 4. And once we have the value of one of the variables, then we will substitute that value into one of the other equations. And then our last step is to write the solution as an ordered pair. So looking at our first system, we have the system 2x plus 4y equals negative 10 and x minus 4y equals 1. So looking at our first step, which states that each equation must be in standard form. So recall that x and y are on the same side of the equal sign, and then our constant is on the other side of the equal sign. So looking at this equation, our first equation in the system, we have our term with our x and our term with our y on the same side of the equal sign, and our constant on the other side. So this first equation is in standard form. So then we look at the second equation in the system, and we see that we have x and our y term both on the same side of the equation, and then our constant on the other side of the equal sign. So both of these equations are already in standard form. For organization purposes, sometimes it helps with elimination to set up a table or to draw some grid lines so that you can set up that column of opposites, because that is the other key piece when we're working through elimination. So I have transferred these equations from the system into this table so that I can easily identify a column. So I have placed my 2x plus 4y and equals negative 10. And notice how I also placed that sign that is in front of that term in that same box, and that will become relevant here in a little bit. And so in the next equation, I have my x term and then my minus 4y. So I didn't put my plus on the grid lines here or the minus sign on the grid lines. I want that sign to go with that term that follows it. And then equals 1. So now I have my system set up in this table, so I need to determine a column of opposites. So recall that opposites have the same number, if you will, but have different signs. So for example, 5 and negative 5 would be opposites. 10 and negative 10 would be opposites. So if we are looking for our opposites, we are looking for columns. So we have 2x and x in one column. And then we have in our other column, we have a positive 4y and a negative 4y. So we should be able to see now that 2x and x, those are not opposites, but that positive 4y and a negative 4y are opposites. So when we are combining these two equations, we can notice that a positive 4y and a negative 4y are going to eliminate one another. So that's that whole piece of the elimination method. So when we combine our two equations, we have 2x and x, which would give us 3x, and we have a negative 10 and a positive 1, which would give us negative 9. So remember that we're combining our equations together. And so that's where that elimination of positive 4y and negative 4y come into play, because that would be a 0y. We wouldn't have any y's there. So then we just need to solve for x. So we would divide both sides by 3. And so x equals negative 3. So now we have the value of one of our variables. So now we're going on to step 5, where we substitute the value of the variable into one of the original equations. So recall that it doesn't matter which equation you choose. So in this case, I just chose the second equation. So x minus 4y equals 1. So now I'm going to substitute the value that I got for x, which is negative 3, in for x in the equation. So I'd have negative 3 minus 4y equals 1. So now we need to solve for y, so I'd add 3 to both sides. and would have negative 4y equals 4. I would divide both sides by negative 4, and so my y value would equal negative 1. And then I would write this solution as an ordered pair, so I would have the ordered pair negative 3, negative 1. Okay, let's try another one. So I'm going to leave those steps up there to follow. And so looking at this system, we have negative 2y minus 2x equals negative 2, and 2x equals negative 12y plus 32. So we need to go through and make sure that each equation in the system is in standard form. So we have x and our y term on the same side and our constant on the other. So on this first equation, we have our y term and our x term on the same side of the equation. So it's close to standard form, and we're going to make that adjustment here in a moment. So the only thing we're going to need to change on this first equation is to put our x term lining up with our other x term. And then our constant is already on the right side. So we're pretty close to standard form on that first equation. So when we look at this next equation, we have 2x equals negative 12y plus 32. So now we can see that we have our x term on the left side of the equation, but then we have our equal sign and our y term is on the right side of the equation. So this one we're going to have to do a little more adjusting with to write that equation in standard form. So if we start with the equation that we have, which is 2x equals negative 12y plus 32, to put this into standard form, we need to move our y term on the same side as our x term. So in this case, we would add 12y to both sides. And so then our equation would be 2x plus 12y equals 32. So these are not like terms. We cannot combine them, but they do need to be on the same side of the equation. So now we have that second equation in standard form. And so remember that I said that this one was really close to standard form. So there's just one thing we need to change with this first equation. And since x and y are already on the same side of the equal sign, the only thing that we need to do is to be able to line up our x terms and our y terms together. So since they're on the same side, we can actually just flip the order of that x and y term. So when we write this, we want our x's to line up in a column and our y's to line up in a column. So we wouldn't want x and then y, x and then y, or y then x. The columns have to be the same terms and like terms. So since those were on the same side, we can reverse that order of those terms. So negative 2x minus 2y equals, and then bring down that negative 2. So when I plug these values into the table, I would have 2x plus 12y and then equals 32. So now we can see our columns. So in our first column, we have negative 2x and a positive 2x, and in the second column, we have negative 2y and positive 12y. So we should see that we have a column of opposites, and so our column of opposites here are our x terms. So negative 2 and positive 2 are opposites. So those are going to eliminate. So now we can combine these equations. So negative 2y plus 12y would be positive 10y, and negative 2 plus 32 would give us a positive 30. So remember, we're just combining these. So if this 32 was positive, so we would have negative 2 plus 32. So then we would divide both sides by 10. And our y value is 3. So now we're going to substitute that value into one of the equations. So I chose to use the first one, so negative 2y minus 2x equals negative 2. And so I'm going to substitute 3 in for y. So that equation would be negative 2 times 3 minus 2x equals negative 2. Negative 2 times 3 is negative 6. So the equation would be negative 6 minus 2x equals negative 2. We would add 6 to both sides, and we would have negative 2x equals 4. Divide both sides by negative 2, so x equals negative 2. So our ordered pair, the solution for this system would be negative 2, 3. So now I'd like for you to pause the video and work out these two practice problems. When you are finished, push play to check your answers. Okay, let's see how you did. So on the first system, 7x minus 7y minus 14 equals 0, and 7y equals 10x plus 7. You should have converted both of these equations into standard form. So in the first one, you would have to move that minus 14 to the right side of the equal sign, and you would have to move the 10x to the left side of that equal sign to get both of those in standard form. And you should have gotten a solution of negative 7, negative 9. On the next system, you should have moved the x term to the left side of the equal sign, and you should have moved then the 5 to the right side of the equal sign, and you may have had to rearrange the order of those x and y terms depending on how you worked that out, but your solution to that system should have been 5, negative 2.